Okay, so today we have to start with module 6, which is traffic learning in ASM. So this module primarily focuses on once you have implemented the ASM policy, and then how you go about checking the learning suggestions, and mainly during the transparent mode, and based on which later on we will do the fine tuning or optimize the policy configuration. So the learning concepts overview. The learning tool was created to assist in building and tuning the security policy. This is relevant for the first activation of web application as an ongoing tool. In both cases, learning actually suggests changes to the policy which would include all future requests of this nature. You can accept URLs and flows that were rejected by the security policy and reject changes to the policy that were caused by actual attacks. So as we saw last time, that we have some URLs that we can add in the policy which are to be allowed, and some parameters we can allow, and also file types and other aspects. Now once you have done that to the best known knowledge of yours and the application, it might be that you might have missed something. So during this learning, if you see that there's something which is getting blocked which actually should not be, then this helps in allowing those things. The main idea of the learning process is to suggest policy changes based on violations. Not every violation has a suggestion, but most do. So whenever we get a violation in ASM, or it generates an alert or it generates a log for an illegal request, it also gives us its own recommendation based on the ASM signatures and based on the anomaly behavior and the policy configuration. So it suggests us that okay, this log that is there, this might be a false positive. So that's kind of a help to us, but we should not take that as the only sole criteria for allowing a particular thing or blocking it. After that suggestion, it's our further investigation which would help us to conclude if we can allow it or we should block it. One of the difficulties in configuring a policy is determining which violations are true and false, and practically this is there's a very thin line in understanding what should be allowed, what should not be allowed based on the suggestions. Because if we 100% rely on those suggestions, then it's a little risky, as in that case we assume that we do not have the knowledge of the application. So true violations means a request was blocked because there was malicious intent behind it. False violations are violations which are caused because this request has yet to be configured and is part of the legitimate use of web application. For this reason, we recommend you start the configuration by learning traffic that is trusted. For example, quality assurance runs traffic and tests the web application. So there is a difference between learning trusted traffic and learning untrusted traffic. Now you examine the requests and responses that cause learning suggestions and then use those learning suggestions to refine the security policy. The result of this refinement process is that the security policy does not prevent legal requests from legitimate users from accessing the protected web application. This is one of the main concerns. We can configure a very strict policy to block most of the things, but the only challenge and the main issues that we face is we sometimes end up blocking such legitimate requests. In addition to learning your web application by violations, you can also learn your web applications by URLs that are known as valid URLs. Violations are grouped by URLs. You can learn the first URL with all its violations, then move on to the next, so on and so forth. So every violation that you see in the logs, it will show you the URL also on which that violation was observed. Then it becomes little easy for us to focus on URL wise, that which URL had what violation. For example, let's say there are two pages on the website and they have, that means they will have two different URLs. Now one URL is a place where you can just upload some files. So on that URL, majorly you will get the violations of file types which are uploaded. So you can understand, okay, file types violation is something that is concerned with this particular URL. And if there's another URL, the second URL is there, which does not have any file type upload or any file upload option, we are not bound to get file type errors there. And because we don't need to allow any file types over there. So we may be focusing on parameters or some other aspect on that particular URL. So URL wise, we can have different logs and different configurations. Wildcard entities can be used to tighten the security policy. The resulting security policy does not prevent legal requests sent by legitimate users from accessing the protected web application. Okay. Learning Manager parses the security policy violations that the policy enforcer generates and generates learning suggestions based on those policy violations. As visitors move through the web application, the Learning Manager captures requests that contradict the current security policy settings and records the learning suggestions on the traffic learning screen. So when we do this lab, we will see that how the Learning Manager generates the learning suggestions. Traffic learning. The data on the traffic learning screen are learning suggestions that the Learning Manager generates. The learning suggestions are categorized by violation type and can represent actual threats or false positives. So learning suggestions in some cases might be true, that okay, this is considered as an attack and they should be further checked. If ASM is not sure about if that is a false positive, it will alert you and say that this requires further investigation. But if ASM thinks based on the anomaly detection that it's a false positive, it will recommend you. It is important to note that the learning suggestions are based on the currently active stack security policy. So the learning suggestions will be based on the policy configuration that we have done. So if we have two policies which are configured for different applications for different configuration, it is not imperative that we will have the same suggestions in both the cases. So the suggestions, the traffic learning patterns and the traffic learning suggestions is based on your configuration. The traffic learning screen displays violations only when ASM detects them in a request or response. So as we have seen that when we see the traffic learning, we have an option to see all the traffic learning, or we have an option to just filter with the illegal request. So whatever filter criteria you're using, based on that you would just see the violations by default, because that's what is selected. Otherwise, if you select all requests, then you might see some genuine request as well. Ignored entities. The ignored entities screen lists the file types, URLs and flows that you have instructed the Learning Manager to ignore, that is, to stop generating learning suggestion for. Typically, the ignored items are the items that you do not want to be part of the security policy. For example, what could be an ignored entity? For instance, if you have made an IP address as an exception and you have whitelisted it. So whatever traffic is coming from that IP, even if that the traffic or the request is violating or creating a violation, since that's a whitelisted IP, so that violation or that anomaly will be ignored. So that would not come under the normal logs of violation, and that would not be blocked if the policy is in blocking mode, but rather if you want to see, you can see under this section of ignored entities where it will log it, but it will not log it in the violation. New entities are those file types, URLs and parameters logged that do not exist in the security policy but match the wildcard entities configured in the security policy. For each entity type, you can review new entities and decide whether to add them to the security policy. So this is how the traffic learning page shows up. In this traffic learning, you see over here test_class. This is actually the name of the policy for which we are looking at the traffic learning, and there are other tabs at the top. Right next to the traffic learning is new entities, and then we have ignored entities, which will show us the relevant data. Now, the next thing is length learning. Length can be learned for each file type. Length for total request, URL, cookie, post data, URI and query string can be learned. ASM then detects the current configured maximum length and average length. Within the accept column, it is recommended you use the 00 rule. Occurrences indicate the number of request occurrences that were rejected for this type of violation. So 00 rule means basically it means that you are choosing an infinite length or no particular length limits. So now what happens, even if you have allowed the file type, let's say JPG, but what happens as per HTTP protocol standards or RFC, a particular length of each file type is defined, which is normal, or which is by default allowed. So like for example, let's say for JPG we were talking about, it's 50 bytes length is allowed. Now if the ASM, now you have configured the file type JPG, okay, that's fine, you have allowed JPG as a file type, but that does not mean that everything that's coming in form of JPG will be allowed. Even if the file type is allowed, the second step check that ASM will do is to check the length of the query. When it will check the length, it will find that JPG query or the request or response has those 50 bytes. If the length exceeds than the defined limit, still the request or the response can be blocked if the policy is in blocking mode. So ASM measures all length violations in numbers of bytes, not by the number of characters. That's pretty obvious. Measuring length violations in number of bytes accounts for the different types of encoding and the number of characters needed to represent one character for the administrator's chosen encoding schema. The lengths of the following HTTP request components can be learned for each file type. Administrator can modify those length suggestions prior to accepting them. Now, if for example the application uses some extra length size, some extra request length for JPG files, so that would be something that we have to define ourselves, because by default ASM is not going to take that extra request length. So the length parameters that can be checked for HTTP traffic is request length. If request length exceeds the default or the defined limit, it's going to block it. URL length, so URL length is also something that ASM is going to validate. query string length. How big is the query string? Is it within the defined limits or it exceeds? So you can imagine now up to how much granular level ASM can check things for considering an attack or blocking it. Post data length. Post data length means, for instance, there is a form on a site that site supports HTTP post method to upload the information on that form. So what is the data length for that information that's posted over there in that form using the HTTP post method? Cookie length. Now cookie by default is there, but if someone tries to insert a bigger cookie than defined or allowed, then that's going to exceed the cookie length, so that will also be prevented. Header length. Now headers should also be default or the defined limit. If it exceeds, that's also going to be blocked. When accepting a learning suggestion, now for instance, like we were talking about JPG, in that case the JPG file, the request length for the JPG files, normally let's say it's 50 bytes, but that application accepts up to 100 bytes. So if we're not sure about that part, if we deploy the normal default configuration of the policy, then all the JPG requests will be dropped because they will be higher in request or violating the request length allowed. So in that case, from the learning suggestion, ASM will tell us that this request was blocked because the request length exceed the maximum allowed. Then you can go back and cross check with the application team if feasible, that what is the request length for JPG files allowed on the website, and if they take, ideally they should tell you that it's 100, and then once you modify based on this learning suggestion, then further request of that size or up to that size will be not blocked. So these are all the things that you can benefit from learning suggestions review. When accepting learning suggestion, ASM updates one or more of the web application security policy to accept the request component that triggered the violation. ASM determines which security policy to update based on the learning accept mode configured for the web application. By choosing the occurrences link, you can establish whether the max length offered by ASM resonated from a legal request. The specified length also contains ASM headers. The length and learning section of the traffic learning page suggests that the length should be 30% larger than the actual detected lengths of each entity due to the inclusion of the internal ASM headers. So ideally, if the application allows 50 bytes, you should make it 30% more, because it's specifically in case of headers, because ASM does insert its own headers in the request and the response. Now in this case, you can see in the screenshot, post data length, current maximum length allowed is 0. So that means it's infinite. Now what is being observed by ASM is 48 bytes. So since infinite is allowed, so all 48, all the requests coming with 48 bytes should be allowed, and that's what we observe. On the right extreme we see accept 63. So all such requests have been accepted and total has been 63. Pattern learning. A pattern is a specific string of text that may or may not include metacharacters. By using attack signatures, ASM can inspect and verify if there are any malicious patterns in a request or response. So pattern learning is something that requires the use of signatures bind to the policy, because pattern learning is something that cannot be inspected without the signatures by using anomaly detection or other features of the ASM. There are approximately 1700 attack signatures implemented in ASM. This is a little old. As of now, it's 1900 plus signatures that is there in the ASM by default. Okay, now meta-character learning. Before we go into meta-character learning, we need to understand what exactly is meta-character from the coding or the the language perspectives. So meta-character basically is any special character. For example, greater than sign, smaller than sign, braces, dollar, exclamation, at the rate, hash, etc. All of these are meta characters, and they appear in your URL also most of the time if you observe. So now it depends upon the language in which the code is written, how many meta characters appear and how they appear and where they appear. So when learning meta character, ASM will display HTTP headers, URI parameters, name and value. ASM learns from top down, so learning suggestions include only the first violating character, even if the violation has several characters. So for instance, let's say all of these characters were present in a request. Now when the ASM looks at this particular request which has all these characters inherent, it will just see the first character, and since that is enough to cause a violation, it will stop further check, and just looking at this, it will block the request and create a log stating that the request has been blocked because of the meta character. So it does not even need to check further because it has found one point of risk. Accepting a meta-character learning suggestion will relax relevant meta-character components of a single or all policies of web application. Now, a few days back, when I was implementing a ASM policy for a application that's called basically Cold Fusion. So you can just simply Google about Cold Fusion. Cold Fusion is a very popular application, and it uses some JavaScripts, and it's basically used for some kind of online payments and billing purposes by some vendors. So that application was written in a very poor way. Now see, that's a standard application, but it's customized by different organizations and developers in different ways to meet the requirements. So if I put over here Cold Fusion, just to see, you get the Cold Fusion hosting, all those things, right? Cold Fusion Wikipedia, you can read about it. Now that application was written in such a way that it had a lot of meta characters, and now as soon as I put the ASM policy, initially I put in transparent mode, I started seeing a lot of alerts. It wasn't blocking because it was not in block mode. So but I saw a lot of alerts. So and in the alerts it was mainly because of meta characters. Sometimes the greater than sign would appear, sometimes the dollar sign would appear. So I went back to the application team, and I mean initially I went back and they said greater than sign is required. I added that as an exception based on the learning that I saw. The next day I saw dollar sign, and I again approached, and the answer was saying that it's required by the application. So I had to make an exception more. For some days down the line, as more requests were coming, I saw that a lot of meta characters are coming in of different variety basically. Then what I've allowed is still new ones are coming. So then they said that the application is such a way that we are not sure what meta character can come. So in that case, I had to allow all the meta characters in the policy, which is not a very secure thing, I'd say myself. But then that's the only way if you are not sure what the application requires and expects. So certain meta characters are allowed by default for URLs and parameter names. All meta characters are disallowed by default for parameter values. Negative security violations are linked whenever a character, regular expression, or attack signature that is not allowed in the ASM security application default configuration list is detected. Accepting violations that occur in negative checks relax the security policies global meta character set. To implement positive checks, flows and individual policies are used. So something of this type you will see in the logs whenever you see a, an alert for illegal meta character in header. So you will see, like, 0x20. Now what is 0x20? If you have coding language idea, 0x20 means a space. So if if the request has some space, or the URL has some spaces in it, then the code would show 0x20 in that space, in that place, basically, I would say. So ASM considers this as a violation by default, because this is something which is equivalent to a space. So that what that means is, actually a space is there present in the request, and that space can be manipulated by an attacker to fill in some suspicious code in that, or a script in that. So now if I look at this, this is something which, this alert makes me think that this should not be allowed. However, I have to, so I can just, what I can do, I can simply select it in the box and click on clear. But before that, I should check this with the application team, because most of the time, since the code is not well written, it's poorly written, this space is something which is to be allowed based on the application behavior and for it to work properly. So then in that scenario, what I will do in this learning, for this learning, I would select in this checkbox and I would say allow. So what this does is, the policy that I have already configured, this would open a pinhole in that policy, and in future requests, if this 0x20 is observed, that such request will be allowed and not dropped. Okay, so this is how, from meta character perspective, you analyze a particular learning suggestion. And this is just one example. There can be many different kinds of meta characters in the request and the response. Even this straight pipe symbol, that's also a meta character. So you have two options: cancel or clear means you are ignoring it, you're not allowing this. Allow means you are modifying your policy to allow it. Violations. The security policy blocking screen displays all of the possible security policy violations for which the system can generate learning suggestions, generate alarms, or block requests if it's in blocking mode. The violations fall into the following categories. RFC violations. So it's very self-explanatory. RFC violations means the violations that are observed based on the RFC values for that particular protocol or feature. For example, the HTTP RFC says the default maximum header size for a request should be 32768 header size, right? 32768 bytes. Now, if the header size exceeds that, then ASM will block it under the category of RFC violation, because there is something in the request that was not as per the standards of the RFC for HTTP. Access violations. Now, access violations means you are trying to, the request is in such a way that the requester is trying to access a disallowed URL or a page, right? For example, now as we discussed, that if you log into your bank account and once you are logged in, then you are checking the summary of your account. If you copy that URL and you give it to me, and I open that URL in my browser, ideally it should not open up that session of yours. It should prompt me to go back to the home page and log in again and then move on. So that just opening that URL in my browser, it's kind of an access violation that the ASM would record. Length violations, we already discussed that this would be the case in when the ASM detects that the length configured for a particular file type is exceeded. Input violations means like there was a place where you had to enter just numeric or numbers and you mentioned alphabets or special characters. So that's an input violation that ASM will detect. So it's very smart. It will categorize in different categories, which makes our job easy to find out why a particular violation or request was categorized as a violation and blocked. Cookie violation, very much self-explanatory. Negative security violations means anything that that was considered a violation based on the signature set. HTTP protocol compliance. Overview of RFC violations. The application security manager reports RFC violations when the format of an HTTP request violates the HTTP RFC. RFC documents are the general specifications that summarize the standards used across the internet and network engineering community. RFCs, as they are commonly known, are published by the International Engineering Task Force (IETF). So now some examples of RFC violations is HTTP protocol compliance failed, which means the HTTP format of the incoming request does not comply with the standards as defined in the RFC for HTTP. Note that the local traffic parser may prevent certain poorly formed requests from reaching the ASM. In these cases, the system does not generate this violation. So that means if LTM itself is dropping, then you won't see a ASM violation log for that. Mandatory HTTP header is missing. The HTTP header is missing in the request. So if HTTP header is missing, then that would be classified as a violation for a header missing. Cookie not RFC compliant. The format of the cookie header in the request does not comply with the standards that specified in the RFC for HTTP. Evasion technique detected. The format of the request contains encoding or formatting that represents an attempt to bypass attack signature detection. Okay, overview of access violations. So access violations occur when the HTTP request tries to gain access to an area of a web application and the security policy detects a reference to one or more entities that are not defined in the security policy as part of the web application. Now, access violation type, illegal entry point. The incoming request references an URL that is not defined as an entry point. Just like, for example, the bank URL where we're saying the bank entry point is the home page where you log in, not the exact URL where you have already where you are checking actually the account summary. Illegal flow to the URL. The incoming request references a flow that is not found in the security policy, right? Illegal file type. The incoming request references a file type not found in the security policy. So illegal HTTP status in response. Server response contains an HTTP status code that is not defined. So in your security policy, you have defined only response code 200 and 300, and the response code coming from the server is 500 something. So in that case, that would be dropped, and this would be the log that you would see. Illegal metacharacter in URL. So the incoming request includes an URL that contains a metacharacter that is not defined in the security policy. That's very much that's pretty much obvious. Illegal metacharacter in parameter name. So the same thing, if the parameter has name that contains a metacharacter that is not defined in the security policy. Illegal method. So you have just, for example, allowed HTTP methods get and post in the policy, but someone is using delete method. So then you will have this kind of log. The incoming request represents an HTTP request method that is not found in the security policy. Illegal session ID, login URL bypass. The incoming request did not access the login URL for a flow access. That's also something, the example that we took for the back one. Login URL expired. The incoming request is for a login URL has expired. Non-existent URL. The incoming request for this URL is not found in the security policy. Request length exceeds defined buffer size. The incoming request is larger than the buffer for the policy enforcer parser. A lot of such violations are there. Now, length violations: illegal cookie length, illegal header length, illegal URL length, illegal post data length, illegal query length. So you can just read the descriptions. It's the same as the name of the violation, and it ends with the illegal request length. The incoming request length exceeds the acceptable length as specified in the security policy. The request length is measured by the total size of the request in bytes, not character. Overview of input violations. Input violations occur when an HTTP request includes a parameter that contains data or information that does not match or comply with the security policy. Input violations most often occur when the security policy contains defined user input parameters. Now, an example of input violation is failure to convert character. Description is the incoming request contains a character that does not comply with the encoding of the web application, and the policy enforcer cannot convert the character to current encoding. Forbidden null in the request. This is a very common one that you will see a lot of time in most of the ASM policies that you define, because by default this null is not allowed. And most of the applications, especially applications which are using Java or PHP, they are using null. So the null is something which needs to be allowed in many scenarios that I've observed. So if your request is getting blocked, just make sure that null is allowed, because even if you have not allowed anything and even if you have not blocked anything and your request is getting blocked, it could be because of this null in the HTTP request. So illegal dynamic parameter value. The incoming request contains a dynamic parameter value that does not comply with the security policy. Illegal empty parameter value. The incoming request contains a parameter whose value is empty when it must contain a value. So even if the parameter value is empty, and the and at the same time the application expects a value, so it would not, the ASM would not allow in that case. Illegal attachment in SOAP message. Malformed XML data. Illegal metacharacter in the parameter value. Illegal number of mandatory parameters. Illegal parameter data type. Illegal parameter numeric value. The incoming request contains parameter whose value is not in the range of decimal or integer values defined in the security policy. Illegal parameter value length. The incoming request contains a parameter whose value length does not match the value length that is defined in the security policy. Note that this violation is relevant only for user input parameters. Illegal query length, query string or post data. The incoming request contains a query string or post data that is not found in the security policy. Illegal static parameter. The incoming request contains parameter whose value is not defined in the security policy. So in this case, you will have to define that parameter in the security policy. Then some XML and related. XML does not comply with format settings. The incoming request contains a SOAP method that is not permitted by the security policy. XML data does not comply with the schema, so SOAP method not allowed. Right, so here's something you can just go through. It's very much self-explained. Then cookie violation. In cookie, what kind of major violations we can observe? Expired timestamp. So if your cookie has expired timestamp, then ASM will not entertain that request, considering that it's an attack. So the timestamp in the HTTP cookie is old, which indicates that the client session has expired. Modified ASM cookie. The incoming request contains an ASM cookie that has been modified or tampered with, right? So when the request initially came, it will send a cookie, and if it observed that the cookie now coming back is a modified one, then it will understand it an attack and block it. This is all we saw, the cookie violation section in the ASM blocking setting the other day. Modified domain cooking is similar, and wrong message key is also similar. Overview of negative security violation. Now negative security violations can be a hell lot of things, because we have 1900 plus signatures by default, and if we add some custom signatures based on the application information, then it goes beyond 2000 plus. So there is a huge number of blockings based on signatures. Negative security violations occur when an incoming request contains a character that does not match the security policy defined character set, or contains a string pattern that matches a regular expression in the security policy's negative regular expression pool. So in that case, the violation that you will get, mostly it will say attack signature detected. The incoming request or response contains a pattern that matches an attack signature. Information leakage detected. The response contains sensitive or user data. For example, if it's a banking application server and it's sending back all the 16 digits of the debit or the credit card in the response, then ASM will block that response, considering it a response that contains sensitive user data, and the logs will say information leakage detected. This is the category of the violation. Unlearnable violations. The learning manager does not generate learning suggestions for all possible violations. You have the option to disable these violations if they do not apply to your web application. The following violations do not provide learning suggestion: modified ASM cookie evasion technique detected, cookie not RFC compliant, non-RFC request. So in this case, ASM will not do any suggestions for you, learning suggestions. Like for example, it will not say accept it or drop it. It will log these violations, but it will not give you any suggestions for these, basically these kind of violations. Non-RFC request length exceeds defined buffer size, failed to convert character, null in multi-part parameter value, illegal HTTP status in response, illegal HTTP format, illegal session ID, login object expired. So all these, well, for all these you'll get a log, so based on that you can allow it, but you won't get any suggestions from the ASM side. So reviewing violations. The learning manager generates violations throughout the life of the security policy. When refining a new security policy, a majority of the violations are actually related to parameter and the parameter values that are missing from the security policy. When the policy enforcer detects the violations, the violations may be related to a real attack and therefore would warrant careful inspection before accepting the violation. You should also carefully review the request for which the violation has generated. Once the violation has been reviewed, you must decide what to do with them. There are three options: accept, clear, or reject the violation, as we saw. So for unlearnable violations, you can either clear the violations or disable the violations. When you accept a violation, the system updates the current edited security policy to accept the request entity that triggered the violation. When you clear a violation, ASM deletes the violation and does not update the security policy, and the learning manager continues to generate learning suggestions for future instances of the violation. When you reject a violation, the ASM deletes the learning suggestion and updates the ignored item list for the security policy. The learning manager does not report future instances. So that's the difference between reject and clear. Clear means, again, if the same violation is observed, it will generate a log and categorize it as violation. But if you just reject it, it will not, for similar kind of request or response, it will not categorize them as violation. Rather, it would categorize in the ignored entities section. Okay, policy blocking is straightforward. The policy blocking screen is where you configure how the security policy reacts to a request that does not comply with the policy. The security policy has two modes, transparent and blocking. In transparent mode, the system generates an alarm and allows the request if the request violates some aspect of the security policy. In blocking mode, the system generates an alarm, does not allow the request, and instead returns blocking response page to the client. On the blocking settings screen, you configure for which violations the system generates learning suggestions and alarms, and if you are using block mode, for which violations the system blocks the violating screen. So as we discussed earlier also, that the blocking can be partial, like for some violations you can put it in blocking mode. For example, for learning, for RFC compliance, you can put it in blocking mode, and for file types or for length violations you can still ignore, and you can put it in transparent mode for those. So you can, even in blocking mode, you can have run in a mix. For some violations you can make it block, for some violations you can make it allow, something like that. So learn, alarm and block. On the policy working settings screen, you can view or enable or disable learn, alarm and block flags for most violations. The flag determines how the system processes requests that trigger the corresponding violation. Learn flag: when the learning is enabled for a violation and a request triggers the violation, the system generates learning suggestions and logs the request in the request information. Alarm: when the alarm flag is enabled for a violation and a request triggers the violation, the system logs the request in the request information and also logs a security event on the statistics security alert screen. For block: when the block flag is enabled for a violation and the security policy is in blocking mode, the system performs the alarm flag actions, as well as when a request or response triggers the violation, as well as it blocks it. Yeah, okay. With a support ID. Okay. The next topic is reporting concepts. Okay. Now, reporting in case of ASM, all right. So we have talked about, and also especially in the last session I remembered, we checked the log section of the ASM, and we saw the logs over there. So that's one thing, we see the live logs, but it's not very easy for us to capture the logs as and when they are generated. because we are not continuously logged into the ASM logs all the time and monitoring it. So what might happen in some cases is that we might miss some log, I mean not miss exactly, but we might see the logs some late and maybe too late to take the action. So that is why reporting is very important and helpful in case of ASM, because when we talk about reporting actually means that configuring the ASM to generate and email the reports. Now what we can get in the reports, or depends how we configure reporting, and this is something which does not have a single standard format, because different people, different environments, and different companies may have different reporting requirement. For example, like maybe you want to for you it's more critical to find out what things have been blocked for that particular policy. So you will for you so you will configure reporting in such a way that all violations are sent to you. For me, what's more important is to find out what URL have been blocked. So I want to see violations by URL. For someone else, they might want to see the violations by the source IP, right? So the violations can happen and can happen due to different reasons. Now, who wants to capture which type of violation and happening due to what reason is something that defines how our reporting is to be configured. Because when I'm implementing, I have to check what's the requirement, and based on that I customize the reporting option configuration. The request list summarizes the requested objects for a web application. A very helpful feature in learning tables is the link between the number of occurrences for an event and the full event information request table. For each web application, the ASM records the requested URLs in the request list. The request screen provides the following information about a request: the request category, the time of the request, the request protocol, the requested URL itself, the server response code, and the source IP address of the request. You can review request information for all web applications if you can view the request informations in the context of a specific web application. There's also a drop down associated with each request that directs you to trigger violation. Now request logs illegal, blocked, and truncated request for a given web application. Request also log responses and response codes. By viewing the request list, you can view information about the date and the time of the request, protocol of the request, requested URL, server responses, codes, and client source IP. So these are all the different criterias which you can choose as a basis of reports, and you can configure multiple reports. One, let's say, based on the source IP, one, let's say, the protocol of the request. So 2, 3, 4, 5 requests, and you can also schedule at what time, like maybe after 6 hours, or after one day, 24 hours, or once in a week, how the ASM should generate these reports, at what frequency, and send it based on the email address that you have mentioned there. Just make sure before configuring this, the ASM or the F5 box should be able to communicate to the SMTP server in your environment, or mail server. You would not like to get all the logs, basically, just the important ones. So like what you want to capture, basically reports can be customized in that way. So when you see the request in the logs, you can filter them, like because by default there would be a lot of entries. So within request, you can filter request based on violation type, source IP address, time of request. These are the filter criteria. request type, responses and response codes, whether request is blocked or truncated, the support ID and the string. A request is deemed illegal if it does not match the security policy. Blocked request may or may not match the security policy, but the action is to block. So filters can be saved and removed. So these are some of the common filters. Illegal request request is not defined in the security policy. If you filter with the web application, it will only show the request for that particular application. Last hour violations that occur within last 60 minutes, last day, last week, last month, and custom you can choose some other parameter. So you can just read this. It's very much straightforward. Yeah, so this is your actually the screen where you filter, and in the drop down you can choose all request, or based on some web application or request type or source IP. You can put, and you can customize in this screen how you want to filter your logs. Actually, response code, if you just put 200, and it will only show you the request that had a response code of 200. Okay, security alerts, we have already seen the alerts about reports we discussed. Alright, so with that the traffic learning is complete. We would be doing the labs for this in the next session, and then we will continue with the parameters, which is